Hello everyone. We're solving statics problems. Our question: the force R in the figure is the resultant of forces P1, P2, and P3 acting on a rectangular plate. Since R is equal to 40 kN and P3 is equal to 20 kN, find P1 and P2. Yes. We have a force system consisting of three forces. These forces lie in the same plane. Therefore it is a two-dimensional force system. We've aligned the force plane with the xy plane. The resultant, or sum, of these three forces is equal to R. The direction and magnitude of force are given. It makes a 30-degree angle with the positive side of the x-axis. Its magnitude is also 40 kN. The magnitude of one of these three forces is given. All of them have known directions. The only unknowns here are the magnitudes of P1 and P2. We are asked to find them, and we will. We have two unknowns. We need two equations. We know that Rx is equal to total Fx, Ry is equal to total Fy. Using these two equations, we can solve this problem. What does Rx is equal to total Fx? In other words, the projection of the resultant on x is equal to the sum of the projections of the components onto x, Ry is equal to total Fy. That is, the projection of the resultant on y is equal to the sum of the projections of the components onto y. Yes. Here, R is the resultant force, and P1, P2, P3 are the components. Now let's find the projection of R onto x. It is seen from the figure. In the positive direction, 40 cosine of 30. We use the given geometry to find the projection of P1. The slope of P1 is 300 by 600. A right triangle with a side parallel to x is 300 and a side parallel to y is 600. Of course, if we simplify these, we see that it is in the ratio of 1 to 2. The perpendicular sides of the triangle are in the ratio of 1 to 2. The hypotenuse is also proportional to the square root 5. Now let's find the x component of P1. By multiplying P1 by the ratio of the side parallel to the hypotenuse, we find P1x, and find its projection onto x. When finding the projection of P2, we again use the given geometry. The slope of P2 is given by the triangle 3, 4, 5. The projection of P2 onto x is positive, which is also positive. P1 is also positive, and P2 has a positive projection. When finding the projection of P2, the side parallel to x is 3. We multiply P2 by 3/5 to find P2x. Finally, let's find the x component of P3. The force P3 is on the x-axis. A force coincident with x, but in the negative direction. It has a magnitude of 20 kN. Then the x component of P3 is minus 20 kN. Let's substitute it. Thus, we obtained an equation. Let's move on to the second equation. We will find the second equation from the equation, the relation Ry is equal to total Fy. Let's find the y component of R. The y component of R is easily found from the figure. 40 sine 30. Let's substitute it. Let's move on to P1. We know that the slope of P1 can be found with a 1/2 triangle. This time we will multiply by the side parallel to y. When finding the y component, we will multiply by the side parallel to y, P1 times 2. We will divide by the hypotenuse, square root of 5. Is it positive or negative? Positive. The y component of P1 is positive. Let's move on to P2. When finding the projection of P2, we will again multiply it by the parallel side to y and divide it by the hypotenuse. But there is something we need to pay attention to here. The projection of P2 onto y is in the negative direction. Therefore we will not forget to put a minus sign in front of it. The projection of P2 onto Y is minus P2 times 4/5. Let's move on to P3. P3 does not project onto Y, because it is perpendicular to Y. Therefore, the Y component of P3 is 0. We have obtained the second equation. Thus, we have two equations for two unknowns. By solving these two equations together, we find P1 and P2. P1 equals 62.3 kN, P2 equals 44.6 kN. Goodbye.